Okay, so today we are going to discuss about very important topic in our ecology lesson. Actually, this is not only important for ecology, but you as the future scientist or science students for the moment. So this lesson going to be very important for your life. I know almost all you have heard about this term or the scientific method, Vidyatmaka Krame. We all heard this word, I'm pretty sure, but I'm not too sure whether you really understand the real concept behind the scientific method. මේක තමයි හුඟක් වෙලාවට තියෙන ප්‍රශ්නේ අපි කොච්චර සයන්ස් කරත් කොච්චර සයන්ස් ඉගෙන ගත්තත් හුඟක් අය මේ මොකද්ද මේ scientific method එක නැත්නම් විද්‍යාත්මක ක්‍රමය මොකද්ද කියන එක හුඟක් අය තේරුම් ගන්න හරියට තේරුම් ගන්නේ නැහැ. ඒකින්දම තමයි සමහරට සයන්ස් කියන සබ්ජෙක්ට් එකම අමාරු වෙලා තියෙන්නේ. Right? So most people believe that the science is so difficult because you don't understand. Many don't understand the concept called scientific method. Right? So we just try to unveil this the concept behind the scientific method. Right? So so we all live in a different environments with different parents, right? In different localities in the country, right? And from your family background, you might have a lot of beliefs, right? Different perceptions, right? From childhood, what you have heard, what you have listened, what you have interact with, who you have interact with, all these are different, right? This is pretty sure, right? So, and along with this, especially with the lot of stories that we heard as child, right? මතකද අපි හඳමාමගේ ගැන කතන්දර වලින් තමයි හුඟක් අය පටන් ගන්න ජීවිතේ as young. Right, we come with all these beliefs and we believe that හරි හඳමාම කෙනෙක් ඉන්නවා කියලා හඳේ හාවෙක් ඉන්නවා කියලා මේ කතන්දර අපි හැමෝම අහලා තියෙනවා නේ. සමහර අය ටිකක් ලොකු වෙනකොට හිතන් ඉන්නවා ඇත්තටම හඳේ හාවෙක් ඉන්නවා කියලා. හැබැයි මේ beliefs තියෙනවා. හැබැයි මේ along with these beliefs and we see the world differently. So different people see the world differently. And that is one of the thing, right? I mean, even the food, taste of a food is even the same food, different people feel that food in different ways. For some it's very delicious, but for some it may be like worse food, right? Likewise, so there are so many differences, right? So similarly, even in the uh, in the science world, the scientific world, we think or we see the world differently, right? So, but in while we are seeing all these things differently, but we need to have one system, one mechanism, one method, or at least a methodology where we can bring everybody into a common ground. Right? මම දන්නේ මේ මම කියන්නේ අනක තේරෙනවද කියලා. අපි මේ විවිධ දේවල් විවිධ විදිහට දැක්කට හැබැයි අපිට විද්‍යාවේදී එහෙම බෑ. මොකක් හරි දෙයක් අපි හැමෝම එක තැනකට ගේන්න ඕනේ. හරි නැත්නම් අපි එහෙම විද්‍යාවක් වෙන්නේ නැහැනේ. ඉතින් මේ ඔක්කොමලා එක තැනකට ගේන්න හදපු ක්‍රමවේදය. හරි මෙතඩොලොජි එක තමයි අපි අතර මේ scientific method නැත්නම් විද්‍යාත්මක ක්‍රමය කියලා කියන්නේ. So the ultimate goal in the scientific method is to find something called the truth. සත්‍ය හොයාගෙන යන එක තමයි මේ විද්‍යාත්මක ක්‍රමේ අරමුණ. Now some people say there is no something called truth. අපි සමහරවිට කියනවා එහෙමනේ සත්‍ය කියලා දෙයක් නැහැ. But at least what we are trying to do, we are going for, I mean, we are finding the path at least towards the truth. Satya soyagena and Satya soyagena marg. And so that is what we really looking at, right? So so similarly, the scientists over the time, and there have been a lot of discussions. I mean, not like us that today with the internet and everything, we have a lot of knowledge about I mean, at least we have understanding about the world that we see. But centuries ago, 1,000 or 100 years, so it's totally different. But at that time also, some people try to solve this issue, like people seeing the same thing different way, and how to, like, especially the scientific people, how we can put this thing into some sort of a methodological thing, right? So that's how this concept of scientific method was evolved or we started, right? So that's the beginning of this term, what we call the scientific method, right? There are a lot of stories behind who invented this. And if you search in the Google in different website, it might say different people, right? So, but it's generally accepted one of the scientists called Francesco Redi, as an Italian physician in 1600, right, 1626. He actually sort of devised this concept called the scientific method, right? Maybe the term they might have not used the same thing at that time, but that's the beginning of actually the term what we call the scientific method, right? So later we will try to understand a little bit more into the scientific method, but in general, we need to have some sort of a background, right? Uh, to be actually scientific, where you need to be a little bit intelligent. Not always this is true. I mean, you don't have to be really intelligent to be a scientist. You can, even within, I mean, without high intelligence, you can do, but it's preferred, or if you are more intelligent, you can be a better scientist. So, right, but you need to have some sort of imagination. This is very important, right? Because you have to imagine something, right? Not just to follow something, right? මේක තමයි අනිත් එක හුඟක් අය මේ සයන්ස් සයන්ටිස්ලා කියලා හුඟක් අය හිතන්නේ මේ දේවල් ෆලෝ කරන අය කියලා. මොකක් හරි අපි ලැබ් එකකට ගිහිල්ලා කවුරු හරි දීපු මෙතඩ් එකක් ෆලෝ කරන අය. But that is not really a scientist job. These are called the technical thing, right? Technicians like job එක තමයි, you just follow the standard format and you do something. That's the technique. But if you are a scientist, you need to have more than that, right? A bit of intelligence and imagination. You have to imagine about something new, right? And also you have to be very sort of creative, right? Now, don't think that all the scientists are very intelligent, they are very imaginative and very creative. It's not so, but if we are really a scientist, they are more imaginative and creative. ඒක නිසාම තමයි සමහර විද්‍යාඥයෝ සමහර අය හිතන්නේ සමහර අයට පිස්සු කියලාත් නේ. Because they have different imagination, right? They see things differently, right? So you may see that they, especially like the famous scientists, right? Sometimes they look like mad because their imagination is very different. They think or they see the world in differently, and that's one of the reasons why they discover new things. They try to see the world in different ways, right? අපේ හුඟක් වෙලාවට එහෙම නොවෙන්නේ ඒකින්ද තමයි අපි කරන්නේ හුඟක් වෙලාවට තව අයව ෆලෝ කරන එක, not the imaginative, right? Or not we are really sometimes creative, right? So then let's see what's really a scientific method is, right? So it's really a sort of a tool that we can use, that scientists can use, right? To support your imagination, right? Especially when you need to solve a problem, right? When you need to solve a problem and you need to find the answer to sort of a question, right? So that's why I use the scientific method, right? But the important thing here, so you use sort of a logical format, right? So you have to use a little bit of a logic here to find the answer to a question that we have, right? So basically it is a sort of a step-by-step process, right? You have to follow a lot of steps, right? Depend on what kind of problem you have. So you have to follow several steps before coming into a sort of a answer to the problem, right? So that's what basically we do in the scientific method, right? So let's see what are the those steps that you would see in scientific method, right? So first thing is you have to identify your problem, right? So the very first thing of scientific method, there should be a problem, right? ප්‍රශ්නයක් නැත්තම් science නෑ ඇත්තට. right? අපි science කියන එක ඇති වෙලාම තියෙන්නේ curiosity හින්දා, අපේ කුතුහලයෙන් හින්දා. ඒක problem එකක් විදිහට අපි දකින්න පුළුවන්. right? මොන හරි දෙයක් අපි දැක්කහම we question about that, why it happened like that, why it is like that, why it is not like anything else, but why it is like that. Then we have to question it, right? So immediate, or the first thing in the scientific method is to identify the problem. What is the problem there? Then you do a little research on that problem, why and how this happened, and you put a sort of a hypothesis. අපි උපකල්පනයක් කරනවා මේක මෙහෙම වෙන්නේ නැති කියලා. Then you really need to do an experiment. Right? After the hypothesis, you have to do experiment, and based on the experiment, it's not only the experiment, but based on the data that you get, it may be observation, right? It may be some data that you can count, right? And based on the data, you come to a conclusion. Right. So it is very important your conclusion has to come from the data, right? Nothing else. So this is very important in science. In the scientific method, you come to conclusion based on data. මේක ඉස්සරහට තව මම උඹලන්ට කියන්නම්. හුඟක් අයට තියෙන ප්‍රශ්නයක් ඇත්තටම මේ අපි සමහරට conclusion වලට යනවා නිකන් අපිට හිතන විදිහට. හැබැයි එහෙම වෙන්නේ නැහැ. එහෙම science එකක් නෙවෙයි. That is not the science, right? We have a video here just to give a introduction to the scientific method. I think you can watch this one.
When you first took science class in school, you probably learned the basic steps of a scientific investigation. You've likely heard of words like hypothesis, experiment, and observation. You may have even memorized a prescribed set of steps. The scientific method is a set of procedures that scientists follow in order to gain knowledge about the world. However, the steps involved in the scientific method vary widely among the different scientific disciplines. Chemists follow the method a bit differently than psychologists. Geologists and botanists have their own unique methods. So is there really one scientific method that encompasses all of science? To find out, we'll need to learn more about the scientific process. There are 6 key steps that tend to characterize the scientific method. The first step is the question. This is the part where a scientist proposes the problem that he wants to solve. A well-conceived question usually leads to a hypothesis, a potential answer to the question at hand. Sometimes hypotheses look more like predictions. The scientist predicts what the outcome will be when he tests his hypothesis. The scientist's test is also called the experiment. Experiments are ordered investigations that are intended to prove or disprove a hypothesis. Important data comes from performing an experiment. The scientist has to make observations of the results that he gets from the experiment. An observation is a statement of knowledge gained through the senses or through the use of scientific equipment. Observations are crucial for collecting data. Once the results are in, the scientist must begin his analysis. Data analysis involves comparing the results of the experiment to the prediction posed by the hypothesis. Based on the observations he made, the scientist has to determine whether his hypothesis was correct. Then he sums up his findings with a conclusion. The conclusion of a scientific process is a statement of whether the original hypothesis was supported or refuted by the observations gathered. The scientific method usually employs all 6 of the steps I mentioned, but the steps don't always occur in the same order. Real scientists may go back and repeat steps many times before they come to any conclusions. It's actually better to use the word elements to describe the steps, since the first step, question, does not always come first. Sometimes, for example, it's an observation that came first and spawned the initial question. Likewise, observations that are made during an experiment can inspire more questions that scientists have to answer. The scientific method is much more fluid than you might think. Let me show you how the steps can feed back and branch out from one another with an example from my own experience. Last weekend, I had a minor ordeal with my internet connection at home. I had started up my laptop and I was frustrated to find that I couldn't get on the internet. I made the observation that my laptop wasn't receiving an internet connection. I asked myself a question: is something wrong with the internet itself, or was it just my laptop? One way to begin answering this question was to check the connection on the desktop computer. Quickly, I formed a hypothesis. If the internet isn't working on the desktop either, then the problem is beyond my laptop computer. The experiment I performed was to check the desktop's connection, and my resulting observation was that the internet didn't work there. So, by analyzing the evidence, I was able to form my first conclusion. Nothing is wrong with my laptop, and something is wrong with the internet connection. Now, this conclusion answered my first question, but it still didn't get my internet to work, so I had to pose another question. Where exactly was the problem occurring in the chain of internet devices? Was it the cord between the modem and the router, the cord between the router and my computer, or was the problem in the router itself? I had to form another hypothesis. If both my internet cords are properly plugged in, then there must be a problem with the router. My experiment was to check both cords and the router. My observation was that both cords were plugged in and that the router was off. I analyzed the evidence, and my conclusion was that I couldn't connect to the internet because my router was off. Are you seeing a pattern here? Once I came up with one conclusion, it left me with another question that I needed to answer. From every question, I got a hypothesis. From every hypothesis, I got an experiment, and from every experiment, I got observations that led me to more conclusions. I don't need to tell you the rest of the story. Eventually, I figured out that my router was unplugged and solved my internet problem by plugging it back in. The important thing to see here is that the scientific method doesn't follow a straight line. It loops back on itself in countless ways. It branches out into new investigations. There's never just one way to answer a question. Keep in mind that the key elements of the scientific method are not the only things that keep science moving forward. It's not nearly as rigid as many textbooks describe. In addition to hypotheses, experiments, and analyses, science requires more subjective processes like creativity, experience, and intuition. In my problem with the internet, I needed to reference my basic knowledge of computerized technology. I knew from experience that unplugged cords were most likely the cause of the problem. But I also brainstormed for a minute or two about other possible causes. I have 2 curious cats and a husband who often changes the arrangement of our cords on the power strip. It's dusty under our desk and the router is getting old. Any of these factors could have affected the connection. I didn't end up pursuing those other possibilities, but I did use plenty of creativity while trying to solve my problem. If it had turned out that my problem was more complicated than an unplugged cord, then I would have had a handful of other ideas to try. Many scientists have used a combination of skills to develop their ideas. Take Charles Darwin, for example. He is credited with devising the theory of evolution by natural selection. It's a biological theory, but Darwin wasn't a biologist. He was a naturalist who studied not only plants and animals, but anything to do with the natural world. Darwin read up on geological principles written by Charles Lyell. He studied theories of economics and population by Thomas Malthus. He bred fancy pigeons and collected natural artifacts on his farm. And yes, he took an amazing voyage to study exotic creatures around the world. Darwin wouldn't have come up with his ideas about evolution without combining all of these influences. It took some creativity and 20 years of research to put all his ideas together. Darwin's work shows that the scientific method is really a fluid, integrated process. It's worth mentioning that scientific studies are kept in check by communities around the world. Most scientific journals employ a process of peer review, whereby scientists critique each other's work and decide whether it meets the standards of the scientific community. Scientists have to pool their resources and check in with one another before they can perform any significant work. But scientists also compete with one another to discover new things. They know that the prize goes to the scientist who gets things right and publishes first. Even Darwin had to compete with other naturalists like Alfred Wallace and Jean-Baptiste Lamarck. But he also worked closely with his friends, Joseph Hooker and Thomas Huxley, who also studied biology and helped him develop his theories. As you can see, the scientific method does not work in isolation. It functions within a community, both inside and outside the realm of science. So it turns out there really is no one way to follow the scientific method. There are key.
Right. I think either you fully understood the scientific method or you fully confused with the scientific method. I don't know which one is right. Right. Maybe for some of you got some idea about scientific method. Maybe for some it's even harder or even confused, because the scientific method, again, as that video shows, it's sort of a several steps, right? And then these steps are not some sort of a standard thing that different people, different disciplines use it different way, right? Like you have, even you're working in your chemistry lab classes, sometimes you write what is the hypothesis likewise, but when you are in the zoology lab or in the aquatic lab, usually you don't follow that same format, right? So same way in different fields you use this in different way. But one thing common is that like the scientific method is not really something very complicated. We do this every day, right? Whenever you have a problem at your home, like in that video, it clearly mentioned about the internet problem, right? Even I mean, you definitely have this kind of a problem within you, maybe your mobile phone, your internet, or right. So when you have this kind of a problem, you use actually the scientific method even without knowing, right? Even without any knowledge about your scientific method, but you follow sort of a similar thing, right? Only the difference in the scientific method, we put sort of in a standard format. So that's the difference, right? Okay, there is another small video as well. Watch that one too.
That should appear in any investigation.
We use the scientific method to understand how the natural world works. We generate hypotheses. We observe, we measure, we analyze, we rate. Yet, when it comes to communicating the meaning and significance of our discoveries, why do we so often use our intuition instead of science? The stakes are too high to rely on our hunches. Just think of all the critical topics in science that suffer from ineffective communication. It doesn't have to be this way. Social, behavioral, and decision scientists have made great progress in understanding how communication fails and succeeds. We should be as scientific about communication as about the science we are communicating. the Sackler Colloquia on the Science of Science Communication, where scientists and communication professionals come together to write a better future for communicating science.
Right. Okay. Now the last video, I don't know if you got some idea about that. It's called the science communication. Right. So this is very important topic in the not only in the science uh, scientific method, but also if you are to be a scientist, right? I believe that all of you are going to be a scientist in the future. So if you are to be a scientific community or a scientist, then this is very important that what's called the science communication. මේකත් ඇත්තටම ප්‍රශ්නයක් අපේ හුඟක් වෙලාවට තියෙන අපේ හැමෝගෙම තියෙන ප්‍රශ්නයක් විශේෂයෙන්ම මේ සයන්ස් කරන අයගේ කතා කරන්න නැහැ මෙතන ඉන්නෙත් එහෙමයි ක්ලාස් එකේ කොච්චර අය ඉන්නවද නේද මේ මම කරන දේ මම කියන දේවල් වල කොච්චර ප්‍රශ්නයක්ද හැබැයි කතා කරන්නේ නැහැ අපි කමියුනිකේට් කරන්නේ නැහැ හරියට ඒ වගේම තමයි මේ සයන්ස් වල තියෙන ප්‍රශ්නයක් අපි this problem is mainly in this even the scientists there are a lot of discoveries by great scientists but there are very few people know about that. Even in Sri Lanka, there are a lot of new discoveries, but very few people know about that. The problem is the science communication. We don't communicate with the general public about our findings. This is this may be too complicated for you, but you see, if you go to a news articles or even the TV news, very few things you will heard about the science invention, but there are a lot of other jargon in news. That's the people usually like, not the scientific information, but for the jargon. That's why all the news channels producing a lot of jargon. Most are not really true. Right. So there are both ways, like the media, they are not very interested on many scientific investigation. On the other hand, even the scientists to be blamed, they are not really communicating their findings. So another thing that you have to remember as the scientist, future scientist, or at least as an ecologist for the moment. So no matter even these small discoveries, you have to communicate with people, right? So I'll come to this one later on, how we are going to communicate these things, right? So let's see, even I have another example here just to show you what the scientific method is, right? I think in that video, it's clearly explained using the internet what is scientific method. In here, I have put another example, something like a very simple example, like a torch. When you try to turn on torch, if it doesn't work, right? Now you can use the scientific method to find the solution for that one, right? So I think it's very simple, right? So if you put the scientific method into this issue, right? So if the torch doesn't work, right? So that is, then you have to put that one as the problem, right? So there are steps. No, the first step is to find the problem. The problem is that the torch doesn't work, right? Then if it doesn't work, then you have to do a little bit of research, or at least you have to go back to the history. If we had a similar situation where the torch didn't work, right? Then otherwise you have to ask from someone why it doesn't work, right? This is sort of doing a research a little bit, right? And if you remember that the reason for the torch not to work, maybe it's the flat batteries or the worn out batteries, to the discharged batteries, right? Then and that is the research problem. And then you put a hypothesis, right? That hypothesis is that the flat batteries or the worn out batteries may be the reason for the why not the torch is not functioning, right? And now what you do a small experiment. You take new batteries and put it into the torch and then see whether it's work now, right? So that is the experiment you do, right? Now if the torch works now, which means, right, that is your conclusion, because your hypothesis was that the worn out or the flat batteries is the reason, and you conclusion that once you replace the battery it works, right? Now the last thing, actually, you're sharing this information. That's the communication part, right? So I just put this very simple question, the example, to see how simple this scientific method is. Actually, it's because we not really understand this concept of scientific method. That's why we think that it's something so complicated, but it's this simple, right? So keep in mind, right? In the next slide, you can see the even you can expand a little bit of the same the steps in the scientific method, right? The first step is the finding the problem, identifying the problem, right? So the question, right? Then do the background information, the background research, right? And this research means you are not doing experiment, but you're finding the background about this issue, right? Then put a hypothesis, right? And then only you do a small experiment. You design an experiment and conduct that experiment, and from that experiment you will get some data or observation sometimes, right? So always it's not the data, but can be some observation, and you analyze this observation or data and decide whether this the hypothesis you put here is true or false, right? And if it is true or false, then you put this one into some sort of a writing, maybe a report or a publication, right? And then you communicate to the others, right? So that is the simple methodology in a scientific method, right? But on the other hand, so if it is true here, that's the end of the story. Perhaps we are not really trying to dig into further. But if it is false, then you have to rethink. You have to go back and you have to change your hypothesis, perhaps, and you have to come back again here. Whether the second hypothesis is going to be true, right? If it is true, it's the end of the story. And even it is false, then you have to think again. Like, this is how, right? So it's no matter what kind of a scientist, even the world famous scientists, right? They never found something easily, like with so much of failures, right? So they have to go back in this cycle several times, right? It's almost all the time, right? It doesn't have to be even this serious scientist, right? මේක හැම ලැබ් එකකම දැන් අපිත් එක්ක ඕගොල්ලොත් ඉස්සරහට ස්පෙෂල් ඩිග්‍රියක් කරත් ඒ නැතත් රිසර්ච් කරන්නේ ලැබ් වල තියෙන හැමදාම තියෙන ප්‍රශ්නය තමයි මේ හයිපොතෙසිස් මොන හරි දෙයක් හිතනවා මේක මෙහෙම වෙන්න ඇති කියලා කරගෙන යනකොට ඒක හරියන්නේ නැහැ, and you have to come back again, you do the experiments again and again, so much or so many failures. මේ failures වලින් තමයි අඳුනගන්නේ, and අපි සයන්ස් වල කියලා මේක trial and error experiment. හරි මේ හුඟක් ඒවට හරියට කරන්න ක්‍රමයක් නැහැ. So you do the trial and error. හරි you have to do a trial, and if it is failed, then you think in a different way the next time, right? So it's pretty much the trial and error experiment. Okay, හොයාගත්ත හුඟක් දෙයක් ඇත්තටම වෙලා තියෙන්නේ. හරි අපි දෙයක් හොයාගෙන ගිහිල්ලා එහෙම කරන්න පුළුවන්. හැබැයි හුඟක් වෙලාවට වැඩිපුරම වෙලා තියෙන ඇත්තට මේ trial and error experiments වලින් තමයි අවසානයේ මොන හරි අලුතින් දේවල් හම්බෙන්නේ, right? So I think at least you have some idea about the scientific method by now, right? It's not really something complicated as we think, right? So these simple steps will help you to understand this scientific method, right? And the important thing, as I mentioned before, these steps, right, always need not to be like in this order, right? Sometimes you like you suddenly you see some observation, and that observation, right, somewhere like here you get the observation, and based on that observation you put some sort of question or hypothesis, and you can test that from like, right? You can start anywhere, even like you may have some concept, your hypothesis concept, and you can start here and go in this cycle, right? Quite say there is no a particular order here, right? අපිට එක එක විදිහට මේක කරන්න පුළුවන්, right? So ඒක තමයි වෙනස තියෙන්නේ scientific method එක, right? Right. Now, so that's the idea behind this concept of scientific method, right? So now this concept of scientific method is very important even in our day-to-day life, right? You might have heard about like many issues, like now these days, the COVID-19 issue. There are a lot of rumors, lot of myths behind, right? Because different people use different different people look at the issue differently, right? So, and since it's a very sensitive topic, a lot of people put in a lot of ideas, and it's so much of information about it, but no one knows what really goes and how it is spread. There are no any agreement, right? Likewise, in Sri Lanka, even there have been a lot of other issues in the history, right? For example, the like agrochemical use, right? How the agrochemical use and how it affected the the kidney disease. Alatina means CKDU can, right? CKDU, right? That some people think that this CKDU is because of the kidney disease is because of the agrochemicals. And there have been a lot of research on this, but still no one knows exact cause of the CKDU or the වකුගඩු රෝගය කියලා කියන්නේ හුඟක් වෙලාවට වේලි කලාපයේ තියෙන මේ කිඩ්නි disease තාම හරියට කවුරුත් නිව දන්නේ නැහැ, right? ඊට පස්සේ කාලෙක මතක ඇති මේ කිරිවල මේ DCD කියලා જાතිය කියලා මේ DCD කියන්නේ ඩයිසයනමයිඩ් මේ මික්ස් වෙලා තියෙනවා කියලා කිරිවල sort of plastic වගේ දෙයක්. ඊට පස්සේ මතක ඇති අර රතු පස්වල මොනවද වතුරේ ප්‍රශ්නයක් තිබුණා. මේ වගේ මේ එක එක myths beliefs එක මේ එන දේවල් තියෙනවා. හැබැයි මේවට සමහරවිට අපි ඇත්තම හේතු දන්නේ නැහැ. හරි වගේ ගොඩක් ප්‍රශ්න තියෙනවා. හැබැයි මේවට මේ scientific method පාවිච්චි කරලා ඇත්තටම විසඳුම් හොයන්න පුළුවන්. That's what a lot of scientists doing that as well, right? So now we'll see how we can use this our understanding of scientific method into the ecology as well as to our understanding about science, right? So what we really try to understand in the science, what we really need to understand is, right, something called the variation versus strain. මෙන්න මේක පොඩ්ඩක් හරියටම අහගන්න. මේ for example, you are measuring temperature, right? Maybe we say in the ocean, you are measuring temperature. Right? If you measure the temperature in the morning, it's different. Maybe daytime it's different. In the evening, it's different. At night, it's different. Right? Because it's naturally varies the temperature because of the sun or the right, the maybe wind or other many factors. The temperature different from time to time, even within the day. Right? So that's what we call the natural variation. Right? And උගල සමහරට දැකලා ඇති අවුරුද්දක විතර ටෙම්පරේචර් මුහුදේ මැනලා මම දැකලා තියෙනවා ගොඩාක් අය හරි එක අවුරුද්දක මාසෙකට සැරයක් විතර ගිහිල්ලා ටෙම්පරේචර් එක මැනලා අවුරුද්දක ටෙම්පරේචර් එක තියෙනවා අවුරුද්දක මැනලා ඉවරලා කියනවා මෙන්න උෂ්ණත්වය වැඩි වෙලා හරි ග්ලෝබල් වෝමින් මෙහෙම ඕන තරම් ආය පොඩි ඒ වගේ එක්ස්පෙරිමන්ට්ස් කරලා කියනවා මෙන්න ග්ලෝබල් වෝමින් කියලා right can it be right එහෙම අවුරුද්දක් මාස ගානේ මැනලා උෂ්ණත්වය එන්න වැඩි වෙනවා කියලා එහෙම කියන්න පුළුවන් ද ග්ලෝබල් වෝමින් කියලා right මෙන්න මේක තමයි අපි තේරුම් ගන්න ඕන දේ මේ හැම දෙයක්ම තියෙනවා natural variation එකක් they change every day every time and that's the natural variation so the whole idea of science is to find in that natural variation if there is what is the trend right මේ variation එකයි trend එකයි මොකද්ද trend එක කියලා කියන්නේ කාලයක් තිස්සේ මේකට මොකද වෙන්නේ කියන්නේ right so we have to understand this the natural variation versus trend there's a small graph here just to show you the natural variation මේ තියෙන්නේ natural variation එක ඒකේ තියනවාද trend එකක් කියලා බලන්න ඕනේ increase වෙන and the look at this the next graph here so this is a good example for you to understand this what we call the natural variation versus trend so this is the again temperature measurement for quite long period of time from 1850s to even up to 2000 right it's the data for long period of time and you can see this change in temperature over the time annual temperature variations right? And you see some very highs and ups and downs everywhere right now in this and all this what we call the natural variation right now if you are a scientist doing some experiments on the global temperature change then you have to understand if there is what is the trend that you can see here do you see a trend of increase in temperature over the time right මෙන්න මේක තමයි වැදගත් මේ natural variation එකෙන් එක්කම බලන්න ඕනේ මොකද්ද trend එක කියලා අපි බැලුවොත් එහෙම මේකේ trend line එකක් දාලා අපිට පේනවා යම් කිසි විදියකට මේකේ මෙහෙම temperature එක වැඩි වෙන එකක් තියෙනවා right so this is really what we need to understand right so since you are still first year you are not really familiar with these kind of things but when you come to the third year fourth year if you are especially doing a special degree now you have to do definitely research project and when you come to there you will definitely understand what I am telling to understand this trend versus sorry the natural variation versus trend මේක මතක තියාගන්න උගා අය වරද්ද ගන්න දේ තමයි මේ natural variations අපි trend එකක් විදිහට හඳුනගන්න අපි ජලාශයක වෙන්න පුළුවන් අපි තුන් පොණ්ඩ එකක ගඟක ගිහිල්ලා ටෙම්පරේචර් ගන්නවා අපි තුන් සතියෙන් සතිය ගත්තා කියලා හැබැයි අපි ටෙම්පරේචර් මයින්නේ එක දවසක් ගිහිල්ලා උදේම අයිනවා තව දවසක් ගිහිල්ලා දවල්ම අයිනවා තව දවසක් ගිහිල්ලා හවසම අයිනවා මේක අරන් ගිහිල්ලා ඔයගොල්ලෝ කොහේ ප්‍රසන්ට් කරාම මේක වැරදිනේ මොකද එක එක දවස්වල එක එක වෙලාවට මැනලා තියෙන්නේ හරි උදේ මනපු ටෙම්පරේචර් එක නෙමෙයි හවස තියෙන්නේ වතුරේ ඒක නිසා මේ අපි එහෙම research එකක් විදිහට කරනවා scientific method එක follow කරනවා නම් if you measure in one location at 8 a.m. in the morning, right, in the following maybe every week or every month, every year, you have to measure the temperature in the same location on the same time. Then only you understand the what is really happening, right? Otherwise you will have so many other factors affecting the change in temperature. So keep in mind, if you are to follow the scientific method, you have to have a certain methodology. You have to have guidelines to measure the parameters, right? So I hope you got some understanding about the scientific method, right? So I don't want to go into very detail. Another thing with the scientific method, I think you might have heard about this concept called the null hypothesis and alternative hypothesis. හරි මෙහෙම එකක් අහලා තියෙනව නේද? අපි සාමාන්‍යයෙන් hypothesis නැත්නම් උපකල්පිත ඉස්සෙල්ලා පළවෙනි එක ගන්න අපි මොකක් හරි එහෙම දෙයක් නැහැ කියලා තීරණය කරනවා. No change, එහෙම නැත්නම් no observation මොන හරි දෙයක් ගැන හිතනවා. We call this is the null hypothesis, right? And what you really do in your research, whatever research you do, you first test whether your null hypothesis is correct. අපි ඉතින් මොන හරි රිලේෂන්ෂිප් එකක් නැහැ කියලා හිතාගෙන අපි මොන හරි දෙයක් කරන් ගියාම ඒක රිසල්ට්ස් වලින් පේනවා නම් ඒක හරි කියලා, that's the end of the story. And එතකොට මේ ආය alternative hypothesis එකක් නැහැ. හැබැයි null hypothesis එක වැරදි නම් එහෙනම් alternative hypothesis එක තමයි හරි. This is what we call the hypothesis testing. මේ උපකල්පිතය ටෙස්ට් කරනවා. මේ කරන එක මේක තමයි අත්‍තරම අපි සයන්ස් වලදී කරන්නේ. මේක දැන් තේරෙන්නේ නැත්නම් අපි හරි තව ටිකක් third year fourth year වලට ගියාම ගොඩ හොදට තේරෙයි මොකද්ද මේ අත්‍තරම මේ hypothesis test කරනවා කියන එක. මේ වචනයෙන්ම මේ විදිහට නොතිබෙන්න පුළුවන්. හැබැයි අපි හැම වෙලාවෙම කරන්නේ මොන හරි observation. අපි සතෙක් ගෙනන් අතර hypothesis නෙමෙයි test කරන්නේ, observations. ඒවටත් අපි මේ concept එක මේක හැම දෙයක්ම ඇතුලේ තියෙනවා. අපි වචන එහෙම පාවිච්චි කරේ නැත. හරි. All right. I hope now you have some understanding, or at least better understanding about scientific method. You were supposed to learn this scientific method from your school. I know that you have already learned these things, but we are trying to understand much better at this stage, right? So now we talk about the 6 like key steps in the scientific method, but is what we call the key methods, but there are lot of other steps in reality if you are really going to be a scientist in the future, right? There are so many other steps actually in between these key steps to follow if you are really going to be a scientist, as you can see from here. Here we have 12 steps, right? Observe or suspect a pattern. ගොඩක් කලාවට අපි ඇත්තටම සයන්ස් සයන්ටිස්ට්ලා වෙන්නේ මේ විදිහ. අපි අලුත් මම කලින් කිව්වේ මොන හරි අලුතෙන් දෙයක් දැක්කම, අලුතෙන් මොන හරි පැටර්න් එකක් දැක්කම, අලුතෙන් දෙයක් දැක්කම ඒක බේස් කරගෙන තමයි අපි ගොඩක් කලාවට ප්‍රශ්නයක් ඇති වෙන්නේ. මොන හරි අපි හිතමු වතුරේ පාට වෙනස් වෙලා තියෙනවා දැක්ක, right? So that is your observation. You saw some sort of observation, and based on that observation you start finding the reason for that one, right? So once you observe and you then make sort of imagination and find what caused this observation, and then you put a question, right? Put a question, you ask a question why it is, right? And then put a hypothesis, in the hypothesis you have a null hypothesis. එහෙම මුකුත් එකක් නැහැ කියලා කියතනවා. එහෙම නැත්නම් ඊට පස්සේ අනිත් alternative hypothesis එක. And you design experiment, collect data, right? The data can be numerical or descriptive, like maybe qualitative, quantitative. Then you analyze data, and you have to use some even statistics, right? So again, very important that නිකම්ම data අරගෙන අපිට කියන්න බෑ මේක මෙහෙම වෙනවද නැද්ද කියලා. We have to use some sort of statistical methods also to see whether the it's statistically significant කියලා කියනවා. හරි. මේකත් ඉස්සරහට මතක තියාගෙන ඉන්න. මේ variations තියෙනවා. හැබැයි මේ වෙනසක් තියෙනවා. හැබැයි මේ වෙනස statistically significant කියලා අහනවා. හරි. දැනට ඔයගොල්ලෝ stats කරලා නැති නිසා සමහරට දන්නේ නැති. හැබැයි statistically කියන්න ඕන මේ වෙනස significant ද නැද්ද කියලා. Statistically significant ද නැද්ද, right? Likewise the evaluation hypothesis, then you make a conclusion, right? So it's very important again, your conclusions are always based on your data, right? Nowhere you have any conclusions other than based on what we data, right? And the other steps, like the problems that you encounter during your research, you have to record these things, and whatever you, when you're writing maybe thesis or something, you have to know what are the problems you had, because when someone else is going to do, they might encounter the same problem. So to avoid this kind of problem, then you have to mention these things, right? And the future direction, if someone doing something similar, what we will advise them to do, something like. And the last thing is the share, right? So it's very important, if you are going to be a scientist, you have to share your finding with others. How are we going to share? There are a lot of methods that we use in the science to share your findings. I'll come to that one in a minute, right? So I hope now we understand at least the key steps, right? So these are the key steps in the scientific method. But as you can see in the previous slide, right, there are a lot of other steps, right? But these are the key steps. And again, remember that you don't have to follow any of these order. You can start anywhere, right? As I mentioned, maybe from observation, you can start a question, hypothesis, likewise, but there is no particular order there, right? So, okay, so that's about the scientific method. But in the next slide, I'm going to talk a little bit about the scientific reporting. As I mentioned, the last step in the scientific method is to share your information, right? So it's very important, if you are a scientist, you have to share your information by means of different ways. I'll tell you how to do that one in a moment, right? So if you are writing a scientific report, which you have already done, I hope, but at least you have done some lab reports, right? But if you are really writing a scientific report, maybe a little more detailed than a lab report, right? But these are the key steps or the key parts you will see in a scientific report, right? I don't know if you have seen a scientific report. I can show later on. It's very important that any of your scientific report definitely need to have a title, right? It's very short title, but the title should really describe what you are doing, right? So මේ title එකක් report එකකට අනිවාර්යයෙන්ම තියෙන්න ඕනේ. ඒ title එකෙන් අඩුම වචන ගානකින් පුළුවන් තරම් හරියටම කියන්න ඕන මොන වගේ දෙයක්ද කරේ කියලා. හරි. මේ title එක හරි වැදගත්. මොකද දැන් අපි ඉන්ටර්නෙට් එකට ගිහිල්ලා එහෙම මොන හරි දෙයක් සර්ච් කරන්නේ හරි ඔගොල්ලෝ ඉස්සරහට සයන්ස් කරනවා නම් සයන්ස් රිසර්ච් කරනවා නම් අපිට හොයන්න වෙනවා ඔගොල්ලෝ මොන රිසර්ච් එකක් කරන එකට කිට්ටුවෙන් යන වෙන අය කරේ මොකද කියලා නේ you search from the මොන හරි වචන ටිකක් Google පාවිච්චි කරලා තියෙනවා Google වලට ටයිප් කරන්න ඕනේ ඒතර අපි ටයිප් කරද්දී පාවිච්චි කරන වචන වලින් තමයි ඊට රිලේටඩ් ඒවා එන්නේ එතකොට මේ ටයිටල් එක අපි හරියට තීරණය කරන්න ඕනේ වෙන අය පහසුවෙන් සර්ච් කරන වචන පාවිච්චි කරන අනවශ්‍ය ජාගන් පාවිච්චි කරන්න ඇත්තටම ටයිටල් එකදී ඒ ටයිටල් එකට පාවිච්චි කරන්න ඕනේ කොමන්ලි පාවිච්චි කරන වචන අනිත් අයට හොයාගන්න පුළුවන් වෙන්නේ තමන් කරපු දේ එතකොට ඒ වගේ right so it's title very important the second one is you need to have a abstract abstract එකක් කියලා එකක් තියෙන්න ඕනේ scientific report එක right maybe if it is a thesis just one page you have in a very summary small summary of the what is your research how you did it what are your observation and what is your conclusion and මේ ඔක්කොම පුංචියට නෙමෙයි අතර summary එකක් දෙන්න ඕනේ so that's what we call the abstract and in your report you need to have an introduction and that in the introduction you give a background to your research right that there you have to mention about the research question and like right so and there should be a literature review right so this is very important you have to do a sort of a literature review you have to find some information about the similar research done by others elsewhere right maybe in this our country or somewhere else who has done the similar work what they have done and what are you going to do right in the science you never repeat someone else's research actually that's why you do a literature review and see what the others have done and what you are going to do is from there onward what is that you are going to do right so you never ever repeat someone else's research unless it's really necessary right if you believe that this what someone else has found is wrong it may be something wrong then you can repeat the same research and to see whether it's wrong or right and then otherwise you never repeat someone else's research that is the sort of agreement in a science you never have to repeat the science right then you have to clearly mention the steps that you have done your research it's called the methodology the method should clearly mention the steps you followed that someone else doing a similar work should be able to follow like for example you are working on one bird research on a bird but someone else might want to do a different animal but they will use the same method right you can follow the same method but you are not doing the same research for the same species in the same way right but you can use the method for different animals perhaps right the methodology and you have the results section that's where in the results you should have only your result right so keep in mind the method is what you have done what you have done not anyone else and only you have to write the method that you follow then the results section you should have only your results right මේකත් මතක තියාගන්න ඕගොල්ලෝ even when you have your lab reports even in the field reports right sometimes you might have to share but try your best to have only your results right because you can't copy someone else's results so you have to use your results then a discussion about the results that's where you put your thoughts why this is different in one place and why it is high here why it is low here something like you put your thought into the results and that's called the discussion you have to have a discussion and you have to discuss the results giving some really the interpret your results right it's not just put a table or graph and you just leave it it's not like that you have to explain why this happened why these variations are there, why it is low and why it is high, something like that, how to discuss. In there you can refer to someone else's as well, or someone else in their research. If they found something, then you have to compare with like this. In the discussion you can have others data, others conclusion, everything, but not in the results or the methods, right? And the last, not really the class, but the next step is the conclusions, right? So it's very important that you make what is your conclusion based on your research, right? And again, the conclusion should be based on your research, right? Not from others, what others, you don't put others' ideas into this one. So from your method, what you have found your results, and from that results, you have to give your conclusion. This is my conclusion about this, right? Okay. So these are the steps. Other than that, you can have something like acknowledgement in your scientific report, like the give some credit to the people who helped you, maybe your supervisors, or maybe the people who helped in the field, or who provided the money or funding for your research. So that's where you have to acknowledge, or the in a lab where they supported your research. So you have to acknowledge that. And the other one is the reference list of references. What kind of a reference, what kind of a documents you have read for your research, for your discussion, and likewise in your project, right? You have to have this list of references. Right. So these are the elements that you will see in a scientific report, right? So මේක දැන් මෙහෙම කිව්වට මම හිතන්නේ හුඟක් අයට තේරෙන්න නැතුව ඇති. මේක තේරුම් ගන්න ඔයගොල්ලන්ට මේ මොකක්ද මේ scientific report එකක් කියන්නේ කියලා මේ report එකේ විදිහව තියෙන මම ඊළඟට කියන්නම්. Right? මේ තියෙන්නේ scientific අපි scientific communications කරන විවිධ ක්‍රම තියෙනවා. Right? So there are different ways of communicating science into others, right? That can be written report, like it can be abstract type articles, reports, or books, right? ඊට අමතරව වෙන oral presentations කියලා. When you find something, there are something like a symposiums or workshops, you do some sort of oral presentation, 10 minutes, 15 minutes body presentation එකක් කරලා කියනවා what you have found, and right, and or otherwise there can be poster presentations. මම හිතන්නේ සමහර වෙලාවට ඔයගොල්ලෝ දැන්නපත් කරලා ඇති වගේ lab classes වලට සමහර වෙලාවට කරන්න කියන මේ වගේ poster presentation where you in a poster you describe your project, what is the title, your introduction, materials and method, results and discussion, and your conclusion. You put in one poster and you explain to the audience about your project, right? So that is one way of communicating, right? Now what to understand these steps, actually I have assignment for you. මේ මං කියපු මොකවත් තේරුම් නැත්නම් මං හිතනවා සමහර අයට තේරෙන්නේ නැති වෙයි. කාට හරි තේරුම් නැත්නම් මොකක්ද ඇත්තට මේ scientific report එකක්, scientific article එකක් කියලා ඇත්තටම අපි සාමාන්‍යයෙන් කියන්නේ මේ science paper එකක් කියලා කියනවා. අපි සමහරවිට නැත්නම් article එකක් කියලා කියනවා. If you are ready to be a scientist in the future, I mean, this is the key thing. You have to write articles or research papers. Papers තමයි ඔයගොල්ලෝ ලෝකයට ගෙනියන්නේ. සයින්ටිස්ට් කෙනෙක් විදිහට වෙන ලෝකයේ අඳුරගන්නේ මේ scientific papers වලින්, articles වලින්. නමත් එක්ක තමයි හැම එකක්ම යන්නේ. So to understand this, what is scientific articles, I have an assignment, maybe another 1 or 2 weeks time. I will put an assignment where in the website you will see a scientific article, and I will ask a couple of questions for you to answer, right? The whole idea is not to read very carefully on the scientific article, but just for you to understand or just to familiarize with the the scientific literature, what is the article, how it look like, what are the content of an article. තේරුණා නේද මේ ආටිකල් එක මොනවද තියෙන කියලා තේරුම් ගන්න පොඩි අසයින්මන්ට් එකක් දෙනවා. ඒකට ලකුණුත් තියෙනවා. ඒක බලලා උත්තර දෙන්න මම ඒක දැම්මහම දාලා ඉවරලා කියන්නම්. Right, so there are other things. If we are really doing science, we have to like evaluate your findings. This is very important, right? Because whether what you have done is right or wrong, you have to decide. That is where you have to evaluate. Right? So it's very important process in the science again. Right? මොනවාරි දෙයක් කරලා අපිට නිකන් ඉන්න බෑ. හරි. අපිට මොනවාරි data ටිකක් කලෙක්ට් කරලා අපි graph එකක් ඇඳලා නැත්නම් මේ table එකකට දාලා පෙන්නනවා මෙන්න results. එහෙම කරන්න මේ තමන් කරපු දේ හරිද කියලා evaluate කරන්න ඕනේ. හරි. මේ evaluation කරන එක එක ක්‍රම තියෙනවා. හරි. ඒකට there are process where you can evaluate, right? I have mentioned several steps here, like do the data address your question. ඇත්තටම අපේ question එකට අදාළවද අපි මේ data collect කරේ මේක බලන්න ඕනේ ඇත්තටම. එහෙම නැත්නම් මේ කතාවේ වැඩක් නැහැ. හරි. something like අර අපි අර කලින් කිව්වේ වතුර sample එක temperature එක මයින් කරලා මේ temperature එක මයින් එක හරියටම එකම වෙලාවෙ කරේ නැත්නම් මේක වැඩක් නැහැ. ඒ කියන්නේ මේ තමන්ගේ question එකට අදාළ නොවේ මේ data collect කරලා තියෙන හැම මේක හරියන්නේ නැහැ. Now the problem is like when you have this kind of research done, and if you publish it somewhere, like if you want to present into a scientific audience, then they will question why you do this. I mean, you measure the temperature in different way and this has no any science, and so you have to do it again. So if you are doing it for research in your degree, you will fail your exam, or otherwise you have to they will ask you to repeat it because what the method you use is wrong, right? So it's very important that you have to follow a format, right? And the second one is, do you have enough data to support your claim? Again, this is very important. අපි මොන හරි දෙයක් prove කරන්න අපි data කීයක් කරන්ද මේ කරලා තියෙන්නේ. හරි. එහෙම data දෙක තුනක් අරගෙන හරි අපි මාස දෙක තුනක data අරන් global warming ගැන කිව්වොත් එහෙම it's never going to happen, right? So you have to repeat it several times. Has the study been replicated? අපි මේක replicate වෙන අය මේකම කරලා තියෙනවද කියලා බලන එක එකක්. එහෙම නැත්නම් අපි මේක කීප සැරයක් කරලා බලලාද මේ අපේ conclusion එකට එන්නේ කියන එක, right? Then there is another thing called the peer review, right? I don't think that you might have heard this term called the peer review. මේක තමයි මේ science වල පාවිච්චි කරන ක්‍රමය. අපි මොන හරි දෙයක් අලුතෙන් දෙයක් පිටිම ආටිකල් එකක් present කරාම it is evaluated by the peers. ලා කියන්නේ අපේ නිකන් යාළුවෝ වගේ අපේ level එකේ ඉන්න අයනේ. හරි. ලෝකේ එහෙම මේ superior scientist ලා කියලා කට්ටියක් නැහැ. හරි. සාමාන්‍ය එහෙම අපි දන්න අය ඉන්නවා. හැබැයි මේ සාමාන්‍යයෙන් කරන්නේ peer review. අපි මොන හරි දෙයක් අලුතෙන් paper එකක් හරි ගත්තාම ඒක අපේ level එකේ ඉන්න කෙනෙක් තමයි ආපහු ඒක බලන්නේ මේක හරිද වැරදිද කියලා. හරි. So this is very important. Not like when you answer a question, like you will be tested by us, the student and lecturers. But when you come to the science, there is no superior or junior in many cases. There can be, but it's called the peer review. Theoretically, the one among us will be reviewed whether what you have done is right or wrong. So peer review is very important. Right, so these are the steps that we have to follow. There are a few other things. I don't want to really go into such detail. Right, so I hope you got some idea about the scientific method. එහෙම නැත්නම් කෙනෙක් සම්පූර්ණයෙන් confuse වෙන්න පුළුවන්. මේ බැලූ complicated වගේ. හැබැයි it is not like that actually. Actually, the scientific method is something very simple. Only thing that we don't really try to understand the scientific method, and that's where you will have a lot of issues, right? Now, that's all about the scientific method, and there's one thing I wanted to highlight, that is the this is the ecology course page, and you might have already seen about the assignment. There is an assignment about the nature diary. I think I did mention in the very first week you have to work on this assignment. Now the whole idea about this assignment also get to familiarize with the concept of a scientific method, right? මේ nature diary කියන assignment එක උගුන්ට දුන්නෙත් ඔය කියන විද්‍යාත්මක ක්‍රමය ගැන තේරුම් ගන්න ටිකක්. Just need to do an observation on animal or a group of animal. You just keep some record, some observation, but it's very important that you follow the scientific method to do this one, right? I have given some guidelines there in the website as well. If you click on this nature diary assignment, you will get some hint about that. At the same time, I have given some example here. මම randomly select කරපු nature diary දෙකක් මේකට දාලා තියෙනවා. You can have look. This is one of the assignment. මේ කිසිම මම bias නැහැ. මේ නිකන් තෝරගත්ත දෙකක් කලින් අවුරුදු වලින් ගත්ත උදාහරණ දෙකක් දාලා තියෙනවා. Right, right. මේක හොඳ examples වෙන්න පුළුවන්. ඔයගොල්ලෝ මෙහෙම කරන්න ඕනෙත් නැහැ. Right, but you just need to follow sort of a scientific method and work on a group of animal or a group of animal, right? And do some experiment, like maybe a very simple experiment, like in this case this student has worked on an ant, right? The title is The Life of House Ant, right? And he or she has done some small experiment to see what are the preferred food type of this ant, right? And put in different type of food, sugar, bread, likewise. I really don't remember, right? That they might they have done a small experiment like and see to which food they are more attracted, right? And with a little bit of experimental procedure, right? And here you can see the different types of food and the observations and at different times, right? And then the observations and findings, right? And do a little bit of analysis also, as you can see here, right? What are the findings and conclusions? And there is a discussion. Actually, the discussion should be before, right? The conclusion and should be in the after the discussion. And that's how he or she has done this assignments. Actually, there should be another one as well. That is this about the talk macaque. Right. This was on the observation on a talk macaque. Right. Right. So this is what you have to do as well. So remember that this assignment will carry 30% your final mark. So you have to do it very good. Maybe this will be a very interesting thing to do if you really like science, and this will definitely help you to get some idea about the how to become a scientist. Right? You don't have to do a rocket science here, just some very basic observation. Right? So it's very important that don't get lot of information from the internet. Right? So මේකේ මම කියලා තියෙනවා ලකුණු දෙන්නේ originality එකට, right? Creativity එකට, right? Scientific background එකට, right? And for the presentation කොහොමද ලස්සනට ඔයගොල්ලෝ මේක present කරනවා කියන්නේ ලස්සන කියන්නේ මේ පාට දාන එකට නෙමෙයි. I nicely presented your results, how well organized, right? මේවට තමයි ලකුණු තියෙන්නේ. Don't put get lot of information to the web and put it here because it has no any meaning. You just need to introduction එකකට පොඩි විස්තර ටිකක් ගන්න පුළුවන් ඉන්ටර්නෙට් එකෙන්. හැබැයි පොඩ දේවල් කොපි කරන්න එපා ඉන්ටර්නෙට් එකෙන්. ඒවා කොපි පේස්ට් නේ, කොපි පේස්ට් කරන්නේ නැහැ සයන්ස් වලදී. Try to write your own. හරි පොඩ ටෙක්ස්ට් ඕනෙත් නැහැ. අතන මේක නිකන් nature diary එකක්. It's not really very scientific report, right? So මම සමහරට උදාහරණ තව examples තියෙනවා. සමහර අය නිකන් PowerPoint slides වලින් පෙන්නලා තියෙනවා. You can discuss later on if you have any question, right? All right, so you can start your nature diary assignment from now on. You have enough time. I mean, right? Deadline එක මට මතක හිටියේ තියෙන මේ නොවැම්බර් අග වගේ. You can work on this assignment throughout this semester, but don't wait for the last moment. And very important, don't select a domesticated animal. හරි ගේ ඇතුලේ ඉන්න බල්ලා පූසා හරි මේගොල්ලෝ ගැන කරන්න යන්න එපා. කරාට කමක් නැහැ. වෙන දෙයක් කියන්නේ වෙන අලුත් දෙයක් නෑ. But you are doing an ecological study, right? Not from a domesticated animal, but you have to select some sort of a nature-based observation, natural observations, but not the domesticated animal. So make sure any animal that come into your home, even a spider or something like, they are not domesticated. They can be inside the home, but they are not domesticated. So you select the animal which has not been domesticated. So where you can present this nicely, right? So if you have any question, anytime you can come to me, or you can put in the even the LMS site. If you have, you can in the news forum you can put some questions where I will always look through and I can help you as well, right? That's all for the day. If you have any questions, it's open for us 5 minutes discussion. If someone has a question, I prefer if you have a question, you speak that everybody can hear. So if you have really difficulty in speaking, then you can use the chat window where you can type your questions. Yes, anyone? Right, so now, I mean, you are very familiar with this online teaching and learning, I guess so, right? So keep in mind that it's not something easy. Perhaps for you, maybe it's not that difficult, maybe just to turn on your computer and perhaps the mobile phone. But for us, there are so much of preparation, right? And we have to use a lot of technological thing, right? Now here, you see I have my laptop, I have my big screen on my left. I have my mobile even, because to give the best possible experience for you, I have to use, like I can see all of you in my big screen, and also your chat windows here. And in my mobile, I see how you see, right? How you can see me and my presentation, I can see from my mobile phone. I have logged in as a student just to see everything's going smoothly, right? I have to look at that one too, right? So, bit complicated thing, and then so what I wanted to tell you is that maximum makes use of this thing for your studies, because we all put in a hard effort on this, right? So you have to make use it. That's the most important thing, and that's where you have to interact. That is the most thing. Then me ඔගොල්ලෝ අහලා ඇති දැන් මේ කියන්නේ outcome based learning. අහලා තියෙනවා ඇති නේද? දැන් කියනවා OBL කියන නැත්නම් outcome based education, OBE කියලා කියන්නේ මේ ඉස්සර අපි කියන්නේ student centered learning. හරි ඔකම තමයි දැන් කියන්නේ. හැබැයි මේක තව ටිකක් එහාට කියලා outcome based learning. So university education has to be student centered, right? ඇත්තටම අපි මේ විදිහට මේ PowerPoint වල දාලා උගන්වන එක නෙමෙයි. ඉතින් එහාට ගිහලා problem solving ඒ වගේ දේවල් අරගෙන කරන්න ඕනේ. ඇත්තටම it's very complicated actually. We have to change the whole education system. It's very difficult to change at once, but gradually we will change the whole system. That's why we give more like assignments, right? It's a different form of assignments, like this nature diary is a sort of a different form of experience for you, right? So that's where in මේ nature diary එක දෙන්නේ එක පැත්තකින් බලනකොට මේ ලකුණු දෙන්න එකට නෙමෙයි ඇත්තටම scientific method එක ඉගෙන ගන්නවා එක පැත්තකින්, අනිත් පැත්තෙන් කොහොමද මොන හරි දෙයක් present කරන්න කියලා ඉගෙන ගන්නවා. ඊට පස්සේ සමහරවිට මේකේ PowerPoint මේකක් හදන්න වෙයි, සමහරවිට වීඩියෝ එකක් ක්‍රියේට් කරන්න වෙයි සමහර කෙනෙකුට, right? You get a lot of skills along with the doing a small project, small assignment, but you will learn a lot of things. So that's the whole idea. Indirectly අපි වෙන ඔයගොල්ලන්ට skills ගන්න අවස්ථාවල් දෙන opportunity. සමහර අය මේ වෙද්දිත් ඒවා දන්නවා ඇති. හැබැයි you will have more chances and you have to improve your technical skills, right? So for example, here we were, and most of us was not very familiar with the Zoom interface, but now almost everybody. මේව තමයි අතන ඔයගොල්ලොත් Zoom ගැන ඉතර දැනගෙන හිටියේ නෑනේ. තාමත් ගොඩක් දන්නේ නැතුව ඇති. හැබැයි දර ඔයගොල්ලොන්ගේ පැත්තට වඩා ගොඩාක් දේවල් තියෙනවා අපිට control කරන දේවල් මෙතන, right? So that's how the technology is transferred, right? So again, me talking here, it's time for you to talk. කාට හරි නැද්ද මොනවා හරි ප්‍රශ්න? Anything about the scientific method or right? So මම අද දැන් ටිකක් වෙලා ගිහිල්ලා හින්දා හැබැයි ඊළඟ දවසේ ඉඳන් නම් අපි හැමෝම හොඳට අහගෙන ඉන්න. මම එක එක්කෙනාගෙන් අහනවා මට මේ නම් තියෙනවා ඔක්කොගෙම.
Excuse me sir.
Yes.
Sir මේ අපි nature diary එක කරනකොට sir ඒකට word count එකක් හරි නැත්නම් pages count එකක් හරි තියනවද?
මට මතක හැටියට බලන්න පොඩ්ඩක් මේකේ මම මෙන්ෂන් කරලා තිබුණා word count එකක් කියලා. මට එහෙම නැත්තම් මම ඒක කරන්නම්. ඒක මේ ලොකු රූල් එකක් විදිහට මම තියන්න කැමති නැහැ. මේ හැබැයි keep the words to the minimum. හරි ගොඩ වචන දාන්න ඕනේ නැහැ. මම හිතන්නේ අපිට restrict කරන්න පුළුවන් maybe 1000 words වලට වගේ. හැබැයි ඒක ලොකු restriction එකක් ගන්න ඕනේ නැහැ. The important thing is the content, not really too many words. හරි හුඟක් වෙලාට wordy වචන තියෙන හුඟක් අය කරන්නේ ඉන්ටර්නෙට් එකෙන් අපි හිතමු butterfly ගැන, සමනලයක් ගැන nature diary එකක් කරනවා. ඉතින් අන්තර්ජාලයට ගිහිල්ලා අර විකිපීඩියා හරි කොහේ එකක් පිටු ගානක් copy paste කරනවා මේකට. හරි සමනලයාගේ හරි උපතේ ඉඳලා ඔක්කොම තියෙනවා ඔකේ පුගේ හරි උපාන්තරණයයි ඔක්කොම හුඟක් අය report වල එහෙම තියෙනවා මට. ඒව ඕනේ නැහැ මේකේ. හරි ඔයගොල්ලෝ research එක කරන්නේ උන්ගේ මේ life cycle එක ගැන නම් ඒව වැඩක් නැහැ මේකට. Right? You have to be exactly what you are going to present in your nature diary. That information only should be there. You don't have to have a lot of information or background information on that. මේක හරි වැදගත්. අපි science කියන්නේ හැම වෙලාවෙම අතරම මේ අපි කියන්නේ මේ summarize කරපු information දෙන්නේ අපි සාමාන්‍ය literature වලනේ අපි කුඩ describe කරන්නේ. හරි අපි ඉස්සර කවියෝ හැම මොනවා හරි කියන්නේ ගම ලස්සනට වර්ණනා කරනවා. හැබැයි science කියන්නේ වර්ණනා කරන එකක් නෙමෙයි. abstract form එකෙන් තියෙන අපි බොහොම කෙටියෙන් කියන්නේ තව කෙනෙකුට ඕන නම් වෙන ක්‍රම වලට විස්තර හොයා ගන්න ඕන එක ගැන අපි ඒකට වෙන අපි කියවපු තැන් ඒ ඔක්කොම reference list එකක්ම දීලා තියෙන එකයි. So keep the word count to the minimum. Good that you asked that question. මට මතක හිටියත් මම word limit එකක් දැම්මයි කියලා හිතන්නේ පොඩ්ඩකින් nature diary page එකේ කියලා නැද්ද word count එකක් ගැන නෑ නේද නෑ මම හිතන්නේ නෑ ඒක දාලා නෑ මම ඒක අප්ඩේට් කරන්න right thank you ප්‍රශ්නය ආවට anyone else right there is a question in the chat window perhaps you can't see it do we have to attach our own photographs or can we get the images which taken from the internet that also a good question right try your best to have your own photographs right so since the nature diary is yours right so you have to have your own photographs always try to get your own one if there is no way of getting photographs හරි අපිට මොකද මොකක් හරි සාමාන්‍ය ලකෝ ඒකෙන් පියාගෙන ගියා ඔගේ ෆොටෝ එකක් ගන්න බැරුණා අපි හිතමු එහෙම වෙලාවක if you really want to get the photographs you can get it from the internet but make sure under that photograph you have to mention what is the source right so it's very important you can't copy and paste just copy and paste some others information or someone else's even images or videos whatever you get and in the your report or your whatever the format you're going to present maybe PowerPoint below photograph you may have a title or even before that you put as a source and a colon and you have to give the at least web address or where did you get that photo from and that shows that that photograph is not yours and the reader knows where you got that photos as well right so keep in mind even for the nature diary or even you are doing a research in the future you can get the photographs but provided that you give the credit to the source හරි එහෙම නැත්නම් අපි මේවට කියනවා plagiarism කියලා අපි ඇත්තටම information වෙන අයගේව හොරකම් කරන ඇත්තටම මේ කියන්නේ හොරකම් කිරීමක් ඒ වචනේම නොවුනට අපි ඒකත් එක විදිහක හොරකමක් කියලා අපි කියන්නේ ඇත්තටම in the science we call the plagiarism right ඒක ඔෆෙන්ස් එකක් ඇත්තටම අපිට ඉන්ටර්නෙට් එකෙන්වත් කොහෙන්වත් එහෙම මේ ටෙක්ස්ට් කොපි කරලා පේස්ට් කරන්න බෑ අපේ ඉන්ෆර්මේෂන් අපි කරන්නේ ඇත්තටම අපි කාගේ හරි ඉන්ෆර්මේෂන් එකක් කියවනම් අපි කරන්නේ ඒ ඉන්ෆර්මේෂන් එකෙන් තේරුම් අරගෙන අපේ වචනේ ලියන්න right අපි ඒකට මේ සයන්ස් වලදී කියන්නේ paraphrasing කියලා paraphrasing right you read something you get the meaning and write it in your own words and you never copy someone else's information as is then it's become plagiarism and copy and paste right හැබැයි ඉතින් අපි හිතමු දැන් ෂේක්ස්පියර්ගේ හරි මොකක් හරි කියපු දෙයක් හරි ඒවයි තිබුණු දෙයක් අපිට වෙනස් කරන්න බෑනේ. අපි හිතමු කවියක් තියෙනවා. හැබැයි එහෙම දෙයක් දාන්න ඕන නම් අපි ඒවා මේ quotation mark එකක් ඇතුලේ එහෙම දාන්න ක්‍රම තියෙනවා. කවුරු හරි කියපු එකක් ඒ විදිහටම දාන්න ඕනේ. ඒවා වෙනස් කරන්න බෑනේ. කවි එහෙම අපිට වෙනස් කරන්න බෑනේ. හැබැයි එතකොට ඒවා දාන ක්‍රම තියෙනවා. හැබැයි ඉතින් අපි සයන්ස් වලදී අපි එහෙම සාමාන්‍යයෙන් ගොඩාක් අඩුයි. Except for definitions. So yes, you have to follow that. You can't copy. There's another question about how do we prepare for the exam paper? I mean, does it include MCQ, structured and essays? That's something I haven't think of. Right? It can be any combination of MCQ and a structure and essays. Pretty sure that I mean ප්‍රශ්න පත්‍රය සම්පූර්ණ MCQ එකක් නම් වෙන්නේ නැහැ. සාමාන්‍යයෙන් නම් මගේ ස්ටයිල් එක තමයි structured plus essay තියෙන්නේ. බොහෝ විට first question එක long question එකක්, then you will have some sort of a structured type question. You will expect short answers and plus another 2-3 questions දීලා එකෙන් එකක් ලියන්න essay type එකක්. Right? So මේ හැම එකක්ම ඩිසයින් කරලා තියෙන එකක් ඔයගොල්ලන්ට මේ ස්ට්‍රක්චර්ඩ් එකකට අපි ඇබ්ස්ට්‍රැක්ට් ෆෝම් අපි ප්‍රශ්නයකට බොහොම කෙටියෙන් කොහොමද උත්තරයක් දෙන්නේ කියලා you have to get that skill. ඔයගොල්ලෝ කලිමුත් කරලා ඇති. ඒ හැබැයි සයන්ස් වලදී ඒක තමයි ඇබ්ස්ට්‍රැක්ට් ෆෝම්. ඊළඟ එක තමයි මේ essay type එකක් අපි අර එක ප්‍රශ්නයක් හරි දෙනවා ඔයගොල්ලන්ට මොනවද describe කරන්න descriptive skill එක ටෙස්ට් කරන්න ඇත්තට මේ ප්‍රශ්න දෙන්නේ. හරි ඒකට තේරෙනවාද මේ ප්‍රශ්න දෙන්නේ ඔයගොල්ලන්ට විවිධ දේවල් ටෙස්ට් කරන්න ඔයගොල්ලන්ගේ ඇබ්ස්ට්‍රැක්ට් ෆෝම් එකේ ලියන්න පුළුවන්. හැබැයි සමහර ලාවට ඔය ස්ට්‍රක්චර්ඩ් ටයිප් එකේ පොඩි MCQ වගේ questions තියෙන්න පුළුවන්. මම මේකදී අමතරව MCQ දෙන්න බලාපොරොත්තු වෙන්නේ නැහැ. මේ එහෙම නැත්නම් ඔන්ලයින් අපිට කරන්න පුළුවන්. මොකද දැනටමත් assignments දෙකක් දීලා තියෙනවා. 40% තමයි අපිට maximum දෙන්න පුළුවන් නේ. ඔයගොල්ලන්ට year end exam එක නැතිව 40% තමයි maximum assignments වල දෙන්න පුළුවන්. දැනටම 10% for the article and 30% for the nurture diary. Then you already 40% is given. Right. I don't have any questions in the chat window. Anyone else want to speak? When I may online classes වලට යන්ති වෙනම මොහොරි ප්‍රශ්න තියෙනවද? සමහරවිට අපේ voice හරියට එන්නේ නැති එහෙම ප්‍රශ්න තියෙන්න පුළුවන්. ඒක ඒ ටෙක්නිකල් ප්‍රශ්න විවිධ දේවල් වලින් වෙන්න පුළුවන්. හරි අපි මේ පාවිච්චි කරන මම නම් මේ headset එක ඒවල් පාවිච්චි කරන්නේ. අන්තර්ජාලයේ තියෙන ප්‍රශ්න වෙන්න පුළුවන්. ඕගොල්ලෝගේ පැත්තේ ප්‍රශ්න තියෙන්න පුළුවන්. ඒ නිසා ඒක ගොඩාක් වෙලාවට විසඳන්න අමාරුයි. හැබැයි ඊට අමතරව වෙන මොන හරි තියෙනවද ප්‍රශ්න? Right. වෙන කාටවත් ප්‍රශ්න නැත්නම් we can stop here. May we know the due date for the article assignment? මේ assignment එක මම තාම දාලා නැහැ. article එක ගැන assignment එක තාම දාලා නැහැ. ඒක සාමාන්‍යයෙන් 7th week එකේ තමයි මම article එක ගැන තියෙන assignment එක දාන්නේ. හැබැයි දැන් ඔයගොල්ලෝ scientific method එක දන්න හින්දා මම ඉදිරි සතියක් ඇතුළත ඉදිරි සති දෙක ඇතුළත මම දාන්නම් මේ research paper එකකුත් එක්ක. එතකොට ඒක කරන්න පුළුවන් පොඩි කාලයක් දෙන්නම් මම ඉවර කර. කාටද ප්‍රශ්නයක් තියෙනවා කියලා කිව්වා? නිපුණේ නේ? raise hand. කෝ නිපුණේ? I got a message that they කාටද ප්‍රශ්නයක් අහන්න තියෙනවද කෝ? වැරදිලා ක්ලික් වුණාද මම දැක්ක මේ raise their hand. All right, if there is no question we can stop here. So everything's fine with you? All right, we'll see again in next Tuesday at 12:30. Right?
Okay, thank you, sir.
Okay.
Thank you very much.
Okay, welcome. And then make sure that you mark your attendance for today's class. මම දැක්ක සමහර අය 12 අමාරුට ක්ලාස් එකට ඇවිල්ලා මේ සයින් කරලා තිබුණා. මම හැබැයි ඒක දැන් අයින් කරා. Then you have to mark your attendance again for the හවස 7:00 series එකට මම අලුතෙන් එකක් add කරා. කලින් එක සයින් වුණා නම් ඒක නෑ දැන්. ඒක අයින් කරලා තියෙනවා. You have to sign in again. Okay, thank you very much. See you next week.